Hi everyone, good evening, welcome back. Can you see my screen everyone? Can you confirm anyone? Am I audible? Fine. Yeah. Fine. In the last session we discussed about SDLC, right? Software Development Lifecycle. Fine. Yeah. So far we have completed four sessions, which are like DevOps introduction, question and answers, technical questions, general questions, and AWS introduction, cloud introduction, and also SDLC, right? Yeah. So these sessions, these four sessions are introductions only, right? So today and tomorrow we are going to work on servers and networks. Okay. So servers, networks, terminology is very important. The terminology is very important. So before going to cloud, before going to AWS, first we need to understand servers and networks basics. Okay. Yeah. So what is server? What is network? What is switch? What is router? What is gateway? What is load balancer? Right? IP address, subnet mask, gateways. So these are all very important, right? Yeah. So in real-time projects, this terminology is very important, right? So that is why before going to cloud, we need to understand this terminology. Fine. Anyone newly joined today? Can you confirm anyone? Anyone newly joined today? So can you share your WhatsApp number and email address in the chat so that I'll provide you all the previous recordings and course content, right? So anyone who already paid and not added into WhatsApp group, let me know. I'll add into WhatsApp group. Okay. So anyone not registered so far, you can register today itself because today also we allowed the same link, right? So tomorrow onwards, the link will be completely changed. Fine. Yeah. Today's agenda here is what is server, types of servers, server client model, best practices and best practices, server architecture. So what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, right? Failover and load balancer. These are all we are going to discuss. So today we are going to discuss up to here, up to operating system. This will take nearly 1 hour, right? So tomorrow we are going to work on networks. Okay. Yeah. Fine. What is server? What is server? Anyone having idea? What is server? Anyone having idea what is server? Guys, real time guys. What is server? Yeah. Server is a computer, right? The server is having high computing power, right? So because developers, testers, build and release engineers, every time, yeah, always they connect their servers, respective servers, and the developers, especially developers, they work on servers only. They develop the code on servers because laptops, desktops will have only one CPU, one hard drive, one storage drive, one memory module, one RAM module, right? So if the module is corrupted, one module is corrupted, or drive is corrupted, or CPU is corrupted, so application will be down, and also, yeah, so the development will be stopped, right? So that is why every developer, every tester, every build and release engineers, so everyone they connect servers, they work on the servers, right? So because server is having high computing power, fine. Yeah, so multiple storage drives available in server, multiple processors will be available in the server, multiple RAM modules also available in the server. That is why, so everyone connects servers and they work on the servers, right? So developers develop the code on servers only. Once development is completed, yeah, they move to testing servers. So once testing is completed, the code will be moved to pre-prod servers. Once the code is moved to pre-prod, so in pre-prod application will be tested. So finally the application will move to production, right? So that is why in real-time projects always we connect servers, we deploy the applications on servers, So developer work on the servers only, right? Yeah. So what is the definition here? See here. A server is a computer that serves information to other computers called clients. So what is other computer? So like laptops, desktops, right? So yeah, the server is a computer. Server is a computer that serves information to other computers called clients, can connect to a server through either a local area network or a wide area network such as internet, right? See here, types of servers. What are the types available? So these are the three popular server types. Okay, blade server, rack server, and towered server. Right. So blade server is a thin server. There is a module here. There is a container. Instead of this container, we can insert this thin servers. These are the blade servers. So normally these servers we can host in enterprise level data centers like Google, UHG, right, and Amazon, right, Microsoft. So enterprise level organizations they use the blade servers. So because blade servers are a bit costlier, very high performance servers. Okay. So next one is rack servers. These are the traditional servers. Most of the data centers they're using rack servers. Tower server. What is tower server? It is a old server, bit old server. So upright cabinet will be available. So in that upright cabinet, the server will be hosted, and one CPU, one mouse, keyboard, and one monitor will be connected to the server here. Okay. So here, let us go with one by one. So blade server is a model server that allows multiple servers to be hosted in a smaller area. So in this smaller area, we can insert a number of servers. Okay. These servers are typically physically thin and typically only have CPU, memory, and integrated network controllers. And sometimes storage drives built in, right? So normally this blade servers will not have any storage drive. But without storage, how can we store the data? Without storage, how can we save the data? So because we connect always we connect external storages, right? Yeah. So here these servers are physically thin and typically only have CPU, memory, integrated network controllers, and sometimes storage drives inbuilt, right? So blade servers are often seen in large data centers like enterprise level. Okay. Yeah. Next one is rack servers. Rack server is a server mounted inside of a rack, right? So normally, so it is a container, big container. Instead of this, we can insert 24 size rack will be there, and also 48 size rack also available. Yeah. So 25, 24 ports rack we can host 24 servers only. 48 host 48 ports rack we can host 48 servers as per the capacity, right? Yeah, so we can insert the server inside of the rack and we connect power network, and we can install operating system, and we can install patches, updates. So after that we can move to, we can hand over to project team developers. Then they start the development. Okay. Yeah. Next one, tower server. A tower server is a computer that is built-in upright cabinet that stands alone and that is designed to function as a server. This is the bit older server. So currently we are not using this. Okay. Yeah, this is a bit older server. Fine. So client server model. Next one is the client server model. See here. Yeah. So this is the server. By using desktops or laptops, we can connect our servers through either LAN network or Wi-Fi or wide area network, whatever network we have. So when we request server, it will give response. When we send the request to the server, it will give response immediately. We can share the data in server centrally, and we can, yeah, we can access the data from central location, right? So this is a client server model. So this is a server and these are the desktops we can connect through network, right? So this is another model, client server model, right? Yeah, through internet we can connect our servers. Fine. So either a desktop or laptop, or even though we can use our tab mobile also to connect our servers through internet with proper authentication only. Fine. Server architecture. Let's try to understand server architecture. So this is very, very important. So while working on AWS services, in AWS we have VPC. VPC is a networking part. So while working on VPC, we can configure network and servers. By the time this is very helpful to you. So this is very, very important. Okay. Yeah. See here, server architecture is the foundational layout or model of a server. So based on which a server is created and are deployed, it defines how server is designed. Okay. So this is the server architecture. This is a typical architecture. While working on cloud infrastructure, I'll show you. Okay. So we'll go deep dive. Now, let us go back to server architecture and we'll discuss about few examples here. Okay. Yeah, up to here it is clear, right? What is server? What is types of servers? What are the types of servers, right? Fine. Yeah. Now let's try to understand server architecture. Server architecture. So we can say here initial phase of implementation. Initial phase of implementation. This is we can say first phase of implementation. First phase. Okay. Yeah. In 1990s and early 2000, in 1990s and early 2000, 1990s and early 2000, how the server architecture, how the project teams they used to design the server architecture, right? Yeah, so let's try to understand. This is very, very important. Okay, so this terminology is very, very important. While working on AWS architecture, you can easily understand if you understand this. Okay, so for example, in first phase of implementation, so we have, for example, we have four applications are there, which are like Java, Python, and also Tomcat, and also one more application, whatever application, like yeah, any tool or any application, Jenkins. So by the time Jenkins was not there, Jenkins is DevOps tool, right? So in 1990s and early 2000, Jenkins was not there. So for example, I'm taking this. Okay, yeah. So here we have four different applications are there, four different applications. These applications I want to host on servers. So in 1990 and early 2000, how the project teams they used to design the server architecture, how they used to deploy the required applications on servers. Here we have four applications, right? Java, Python, Tomcat, Jenkins. So in 1990s and early 2000, the project teams used to take, yeah, for each application they used to take one server. For each application they used to take one server, right? So here there are four applications, right? They used to take four servers for four applications. These are the four different servers. Yeah, so these servers we can host these applications. See here. So by the time 1990s and early 2000, highest capacity of the storage is 1 GB. 1 GB storage. Highest capacity of the storage in 1990s and early 2000, highest capacity is 1 GB only, right? So these are all 1 GB servers. These are all 1 GB servers. Fine. 1 GB servers. So here, project teams used to take four servers for four applications. So in this first server, they deployed, for example, Java. So Java will be occupied, so 300 MB, for example. Okay, 300 MB will be occupied in this 1 GB. So remaining space will be wasted, right? Remaining 700 MB space will be wasted. Okay, yeah. So Python will occupy, for example, Python occupied here 350 GB, for example, 350 MB, not GB. Okay, so remaining space will be wasted, right? 650 MB will be wasted, right? And also Tomcat occupied 400 MB, for example. So remaining 600 MB will be wasted here, right? And also Jenkins, for example. Jenkins occupied 500 MB, for example. Remaining space will be 500 MB will be wasted. So this is initial phase of implementation. So in 1990s and early 2000, so project team used to create servers like this. They used to deploy. So on each server, one application on each server, right? Yeah. So here, yeah, what happened in this initial phase of implementation? So utilization is very less. Utilization is very less, right? Server utilization is very less, but costing it was very higher. So by the time in 1990s and early 2000, hardware costing it was too much costing, right? So even though if you, yeah, so by the time, so even desktop costing also, okay. So higher costing and less utilization. So that is why, yeah, project teams used to spend more budget on the hardware by the time. Okay, that is why. So this concept is failed. This concept is failed because higher costing, right? Utilization is less. That is why this was failed. Okay, this concept. So initial phase of implementation, it was failed. Yeah. In second phase of implementation after 2000, in second phase of implementation, so in second phase of implementation, what happened here? Yeah, project teams used to take high-end capacity server, one server. Project teams used to take one high-end capacity server, and they used to deploy all the packages on same server. In second phase of implementation, project teams used to take high-end capacity server, high-end capacity server. So they used to deploy all the packages on the same server, Java, Python, and also Tomcat, and also Jenkins. All the applications they used to deploy on same server, right? In second phase of implementation. So it is fine, but here some drawbacks are there. What are the drawbacks here? So Java user may access Java application. Python user may access Python application. Tomcat user may access Tomcat application. Jenkins user may access Jenkins application, right? So respective applications they are accessing here. Okay. Yeah. So here there may be chances to access Java user may access Python application also. There may be chances to access Java user may access Python application. So Python user may access Tomcat application. Tomcat user may access Jenkins application. There may be chances here, right? So security layers will be there, but there are chances to access other applications also because the four people are accessing same server, right? They're logging into same server. That is why there may be chance to access other applications also, right? So that is one of the drawback. That is one of the drawback. For example, four people are staying in two bedroom homes, two bedroom house, two bedroom flat. Okay, so two people are staying in one bedroom, other two people are staying in other bedroom. So the four people commonly access kitchen and dining, right? The same way here also. So the four people are logging into same server. There may be chances to access other applications also, right? Yeah, that is one drawback. And also, if the server is crash, if the server is crash, what will happen? All the applications will be gone, right? So this is also one of the drawback, right? So that is why this is also failed concept. Second phase of implementation also, it is also failed because of drawbacks, right? Yeah. Now let us go and work on third phase of implementation. Discuss about third phase of Third phase of implementation. In third phase of implementation, virtual servers came into the market. Virtual servers. Okay. So let us say VMware servers. Let us say VMware. What is VMware? Everyone understanding, right? Everyone knows. So VMware is a virtual software. VMware is a virtual software. Yeah, that we will discuss later point of time. So while working on cloud concept, we'll discuss about VMware, Citrix, and all. Okay. Yeah. Now, see here. In third phase of implementation, virtual servers came into market, right? Yeah. So here in virtual environment, what will happen? We take one physical server. We take one high capacity physical server. Okay. This we can say base OS, base operating system. So this is physical server. This is physical server. Base OS, base OS is the it is a physical server. It is a physical server. Base OS is a physical server. Yeah. So this is a high capacity server. We take one physical server, high capacity server. On top of that, we install one software which is VMware, VMware or hypervisor or Citrix, right? So this is a software. This will allow you to create virtual servers. This software will allow you to create virtual servers on top of this server. Okay. Yeah. So what is virtual server? Anyone? What is a virtual server? What is virtual server? Anyone? Virtual server is a imaginary server, not which is not physical server, right? Virtual server is a imaginary server which is not physical server. Fine. Yeah. So we take one base server. On top of that, we deploy VMware hypervisor or Citrix. So on top of that, we can create virtual servers. We can create virtual servers like this. Okay. So here we can create here virtual servers. 5 into 5. So 25 servers. As per the server capacity, base server capacity, we can create virtual servers. So these are the 25 servers, right? So on these servers, we can deploy different operating environments, different operating systems. Like here, I can deploy RHCL, Red Hat Enterprise Linux. Here I can deploy Windows 2019. Here I can deploy Ubuntu Linux flavor. Here I can deploy Windows 2022 also available currently. And here I can deploy CentOS is the Linux operating system. So we can deploy 25 operating systems, different operating system if you need as per the requirement. Okay. Yeah. So this is successfully running, but still drawbacks are there. This virtualization is running successfully. Project teams are using, but still drawbacks are there. What are those drawbacks? Okay. What are the drawbacks available here? For example, if you want to install operating system on a server, so before that, so these are the 25 servers, right? So how these servers will work? This servers will take the resource from this base server. This virtual servers will use the resource like RAM, CPU, hard drive from the base server. Okay, so this base server will have high capacity RAM for example 48 GB, CPU for example 32 core, and storage HDD or SSD. Here we can have, yeah, so 10 TB, 10 TB or 12 TB like that. Okay, so these virtual servers, they use the Storage from storage and CPU and RAM from the physical server, base OS. Okay, yeah. So here still we are using in the projects, but here we have some drawbacks are there. Drawbacks. What are the drawbacks available here? What are those drawbacks? Okay, yeah. So when you want to install operating system on a server, we need one ISO image. What is ISO image? It is a, yeah. For example, in your laptop, if you want to install operating system, what we required? What we required? So if you want to install operating system on your laptop or desktop, if you want to install operating system, what we required? We required image, right? We can copy image into pen drive and we can connect to our laptop and we can configure as a bootable drive, pen drive. By using that pen drive, we can install operating system on the laptop or desktop. Same way in virtual environment, we use the ISO image. ISO full form here is International Standardization Organization. So International Standardization Organization. This is the full blowing operating system image. So fully configured operating system image. Okay. So by using this, we can install operating system here, right? So this ISO image size would be, yeah. So minimum, not 1 GB, minimum 6 GB to 18 GB. So this image size, ISO image size, minimum 6 GB to 18 GB, right? Yeah. So and also when you want to reboot the server, when you want to reboot or restart, both are same. When you want to reboot or restart virtual server, it takes 4 to 8 minutes. It takes 4 to 8 minutes. Okay, so when you want to restart this server, it takes 4 to 8 minutes. Fine. Yeah, and also here deployment time and downtime is higher. Deployment and downtime is high. Deployment time and downtime is higher, right? Deployment and what is deployment time, anyone? What is deployment? When you want to deploy any packages, when you want to install any packages, or when you want to deploy the code, when you want to deploy any applications, that takes more time. And what is downtime, anyone? What is downtime? Anyone real time guess? What is downtime? Anyone? Yeah, server maintenance time. We can say maintenance time. Okay. So deployment time and downtime is higher in the virtual or physical servers. Okay. So these are the drawbacks, right? So for example, if you want to deploy operating system on a server, so we need to spend 6 GB to 18 GB storage for only operating system. On top of that, again we deploy patches, applications, plugins, drivers. So whatever we require, we can deploy all the packages, right? Yeah. So this take 6 GB to 18 GB. So on an average, for example, on an average, so here we have 25 servers, right? On an average, each server is utilizing 10 GB, for example, 10 into 25 servers are there. So here we need to spend 250 GB for only operating system. Here we need to spend 250 GB for only operating system, right? So on top of that, again, we need to deploy all the plugins, patches, and all, right? Yeah. So here storage costing is higher. This is one of the drawback. And also whenever you want to restart or reboot, so it takes 4 to 8 minutes, right? Normally, client will not accept for 4 to 8 minutes. So for example, Flipkart server is there. Flipkart is running on a server. If you restart a Flipkart server, it takes 4 to 8 minutes. So that much of time client will not accept because business will be impacted, right? This is also one of the drawback. Fine. So when you deploy anything, any applications, when you want to down, it takes more time. So these are all drawbacks. So that is why currently project teams are looking for advanced environment, so which is third phase implementation, which is very very important for us, right? Yeah, so fourth phase of implementation, which is we can say Docker containers. Docker containers. Okay, this is very very advanced topic, advanced topic. So while working on Docker, we'll go deep dive in DevOps. So now let us try to understand the overview of this. Okay, so in fourth phase of implementation, we use Docker containers, right? Yeah, how it would be, how we can configure, what are the things available here. Let's try to understand. High level architecture, we'll try to understand here. Okay. Yeah. So the same way here, as we take a physical server here on third phase implementation, we can take one cloud server here. We can take one cloud server. So which we can say this is AWS server, for example, AWS EC2 instance. So terminology is very, very important here. So EC2 instance is a server. In AWS, we'll call it as EC2 instance. EC2, what is EC2? EC2 full form is Elastic Compute Cloud. EC2 full form is Elastic Compute Cloud. Okay, while working on AWS, when we start working on AWS. So day after tomorrow, we'll start AWS, right? So by the time we'll understand this. EC2 is the Elastic Compute Cloud instance. EC2 instance. Yeah, it is server. Okay. Yeah, we can take one AWS EC2 instance, which is server. So on top of that, we can deploy one package, which is we can say Docker image. We can deploy one image, which is a Docker image. Once we deploy the image, this will allow you to create containers like this. Okay. Yeah. So these are the containers. These are the containers. In these containers, we can deploy operating environment as per the requirement. Here I can deploy Windows. Here I can deploy RHCL, Red Hat Enterprise Linux. Here I can deploy SUSE Linux, SUSE. Here I can deploy Amazon Linux. Right? So like this, whatever operating environment we required, we can configure it. So when we run the container, when we run this container, it takes only lib and bin files, lib and bin, library and binary files. When we run the container, it takes only library binary files. So whatever files required to deploy the applications, okay, those will be available in the containers. So containers are very lightweight, standalone, right? So we can move this container to anywhere, we can use anywhere. So when we talk about container is it's like a box, right? So in general, container is a box. That container we can move anywhere, we can use anywhere. Fine. Yeah. So when we run the container, it takes only 200 MB of the size of 200 MB size of the, yeah, it takes 200 MB only occupied in the container. So here when you create a server, it takes 6 GB to 18 GB, right? But a container will take 200 MB only because this is lightweight. It takes only bin and lib files only, required files only to deploy the applications, to deploy the, yeah, to deploy the code. So whatever files required, yeah, this context will take that files only, right? Yeah, so only 200 MB will be occupied for operating environment. On top of that, if you install packages, drivers, patches, so maximum it will take 650 MB only. 650 MB only. As per the requirement, we can deploy the packages here. Okay. So when you restart container, restart or reboot, so it takes 15 seconds, 15 seconds only to restart the container. So quickly it will be restarted. The developers who are working on the containers, they will not understand, right? If the container is restarted or not. Okay. Yeah. And also here, deployment time and downtime is very less. Right. So these are all advantages of containers. These are all advantages of containers. Okay. So deployment time and downtime is very less. So that is why every project team they are looking for Docker containers. So currently we are using digital applications, right? Like Flipkart, Amazon shopping site, Myntra, Meesho, Trends. So these are all digital applications. Those applications hosted in Docker containers. So that is why when we book any product, so that they deliver within hours also, within minutes, within 10 minutes also, groceries will be delivered. So groceries we receive within 5-10 minutes, right? Because of backend they are using advanced architecture, advanced infrastructure, which is Docker infrastructure, right? So yeah, in 2020 lockdown time, everyone used the online shopping only, right? Because of Docker containers. Okay. Yeah. So from 2020 onwards, it is evolving, and now yeah, every application they are using Docker containers, right? So because quickly the request will be processed in the Docker containers, right? Yeah. So this Docker in real-time projects, so accessing Docker containers, working on Docker containers are very easier. So it's very faster, right? So quick response, fine. So moreover, very important advantage, which is cost effective, very less costing. That is why. So every project in they're looking for Docker containers. So client always look for the cost saving, right? So that is why, yeah. So Docker containers are currently very popular. So most of the project teams they are using Docker containers here. Okay, yeah. So Docker launched in 2013. Docker implemented in 2013. Okay, so immediately after 1 year, Kubernetes released. Kubernetes, yeah, 2013 Docker released. Immediately after 1 year, Kubernetes released. Kubernetes released in 2014. So because Kubernetes is advanced to Docker, Kubernetes is advanced to Docker, right? Yeah. So before Docker, before Docker, we used to use some containers. Before Docker, also we have containers, right? Before Docker, what happened? We used to use some containers. So what are those containers we used? Okay, LXC, LXC, and Jones, LMCIFI. So these are all containers we used to use before Docker. So LXC, what is LXC? LXC is it is a Linux container. Linux container. Jones is a Solaris container. LMCIFI, full form is let me container for you. So this is Google container. Google container. So these are the containers we used to use before Docker. So these containers are failed. These containers are failed. Why these containers are failed? So these containers are failed because of these are all platform dependent containers. These containers are these containers are platform dependent containers. What is platform dependent? These are all platform dependent containers. What is platform dependent? Anyone having idea? What is platform dependent containers? Anyone? Real time guys. Yeah. Platform dependent is OS based. Only run on respective platform. Right? Yeah. So here Linux, yeah, LXC run on only Linux platform. Jones run on only Solaris. LMCI FI run on only Google. Right? So that is why these countries are failed. These are not popular. Okay. So Docker Docker is platform independent. It is a platform independent infrastructure, right? Platform independent. What is platform independent? Anyone? What is platform independent? Docker containers will run on any platform. Docker containers run on any platform like Windows, right? Linux, Solaris, even macOS also, right? So irrespective of operating system, we can run Docker containers on any platform. These will run on any platform. That is why. So these are all very popular now. These are all very popular now, right? So currently we are using this, right? Currently we are using this. These are all very popular now. Fine. So most of the organizations they are using Docker containers. So because of very faster, quick response, and also cost effective. So that is why. So every organization they are using Docker containers, right? So while working on Docker, we'll go deep dive, right? So Docker will take nearly 8 days to 10 days while working on Docker. So nearly 8 hours to 10 hours. Okay, we'll go deep dive. So Docker containers are very popular. Clear, right? Up to here. Any questions, anyone? Any questions, anyone? Up to here. Anyone having any questions? You can ask me now if you have any questions. Clear, right, everyone? Up to here, it is clear, right? Fine. Yeah, any applications? Yes, someone asking some question here. Yeah, Pradeep asking some question here. Pradeep or someone. Okay, so will container Docker support jar, var, any file formats, any archive files. Docker supports. Okay. Yeah, someone asking. I am confused if really in 8 days Docker will be thought and will. Yes, we'll go deep dive. So 8 days to 10 days nearly. So whatever real-time activities we are performing, we'll go deeper, right? We'll go deeper. And also how Docker is able to be universal. Does it do not plugin? So this is freeware available, and also they have two editions are available here: community edition and enterprise edition. So normally in real-time projects we always use the enterprise edition. So practice purpose you use community edition only. Practice purpose we use community edition. Docker and Kubernetes nearly takes 20 hours, 20 days. Docker and these two are very popular. So because Docker required for Kubernetes, Kubernetes required Docker. So Kubernetes is having some dependency, Docker required for Kubernetes. Okay. Yeah, daily recordings we upload into Google Drive. You can access from Google Drive. Fine. Any other questions, anyone?
Ram Pradeep here.
Yeah, go ahead, please. Yes.
So, at least I just wanted to ask one question. So, regarding you said Java and other things as application, right? So, are they not a software actually?
These are all applications. Yes, these are all applications.
So, at least for me, I mean, as per my understanding, what I thought is like a Flipkart or WhatsApp or whatever it is. So, those are
Hmm.
the application, and like this Java or like SQL, whatever it is. So, I thought those are like a software. So in that
Yes.
we develop a program and whatever it is, like if it is Flipkart or Amazon, whatever it is, we develop a
Yes.
program using those softwares and
Mhm.
then we publish those applications. So that is what my understanding was. But while you are saying it, you are also referring these like Java and all this as applications, right?
Mhm.
So just makes me quite confused on that.
Yeah. So normally, when developer develop any application, right? That application
Hmm.
should be converted into one artifact. Artifact is nothing but archive file. Yesterday we discussed, right? Artifact
Yeah.
means war file, jar file, ER file. As per the application, Maven will convert into artifact. That
Mm-mm.
artifact will be deployed onto containers. You understood, right, everyone? That artifact we can deploy onto containers as well as servers also, as per the requirement. Any language it supports, we can deploy any war file, any jar file, any ER file. So don't confuse. We'll go deeper. We'll go deep dive while working on Docker and Kubernetes. So you'll understand. Okay.
Okay. Yeah.
Yeah. Someone asking Google Drive link. We'll share with you once you add into WhatsApp group. Okay. So because Google Drive is created and we upload some documents and also links, recordings, right? Will provide uh, from Monday onwards. Okay. So if you are added to WhatsApp group, so you can, yeah, you'll get the link very soon. Okay. How many students current batch? 15 guys already registered. So again, another 15 members also they are going to register. So currently these are basics, right? So still we are working on basics, right? That is why. So still people are waiting. So from maybe from Friday onwards, people will be added. Friday we have AWS, right? Minimum 25 to 30 members. Minimum 25 to 30 members will be there. Okay. Yeah. So next one. Yeah. Next one is operating system, right? What is operating system? Anyone having idea what is operating system? Operating system. What is operating system? Anyone? Anyone having idea here? What is operating system? Yeah, so every laptop or desktop or server hardware understand only binary language, right? Binaries like 000001111001111 like that. So every system, every server, every laptop, every desktop understand only binary language, binaries. Fine. Yeah. So, but human will not understand binary language. Human will not understand zeros and ones. That is why we required one translator, which is nothing but operating system, which is interface, which is nothing but operating system. See here, operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? So zeros and ones, hardware will understand, that will convert into binary language, right? So here, so in between hardware and end user, we have a layer which is operating system, right? Types of operating systems, okay? Here we have single user single tasking operating system. So in this type of operating system, only one user can log into the system and he can perform only one task at a time, right? Which is nothing but single users, single user, single tasking operating system. Okay. So this is, for example, MS DOS, Microsoft Data Operating System. This is very old operating system, right? Yeah. Second one is single user multitasking operating system. So in this type of operating system, only one user can log into the system. He can perform multiple tasks at a time, which is nothing but Windows. Normally, while working on Windows, so we can operate multiple tasks, right? Like for example, while browsing internet, we can run background audios. While working on any activity, we can perform, we can run audios, background audios, right? So which is nothing but single user multitasking operating system. Next one, third one is multi-user multitasking operating system. So in this type of operating system, multiple users can log into the system. They can perform multiple tasks at a time. So which is nothing but Linux and Unix. So in Linux and Unix, multiple users at a time, they can log in. They can perform multiple tasks at a time. For example, while deploying application, so developers log into the servers, testers log into the servers, DevOps engineers also log into the servers, right? They perform their own activities, right? So these are the types of operating systems. So we have in Linux, we have different flavors are there. Amazon Linux, Red Hat Enterprise Linux, SUSE Linux, right? And also Ubuntu, Amazon Linux, different operating systems are there, different flavors. In Windows also we have different Windows flavors are there. Fine. So these are the operating system types. So networking part we'll see tomorrow. We'll start tomorrow, right? Yeah. So any questions so far, anyone? Anyone having any questions? So tomorrow we'll discuss about networking part. Anyone having any questions so far?